Hello everyone, today I'm going to solve a Leetcode problem 1000 to find common characters. Given a string array words, return an array of all the characters that show up in all the strings within the words, including duplicates. You may return the answer in any order. So let's take an example one. First example, words. So we have these words, right? So the common characters in all of the words are just these three characters, and so let's how these are just as you can see, like we will have is found in all of the characters once, right? And L found in all of these twice, right? As you can see, it found is in twice in all of these words, right? So what we're asked to find to return is an array of characters which show up in all of the characters, so including the duplicates, right? So how do we solve this problem? How do we going to solve this problem? So let's count the first. Let's take the count. Let's look the characters count the first word. Let's say we have B is how many B's we have for the first word. The words in the word sorry, the first word, the first word. We have one, right? So how many E's we have? We have how many E's we have? One E, right? How many L's we have? We have small a, right? How many L's we have? We have two L's, right? How many A's we have? We have only one A, right? So this is gonna be the count of the first word in this array. So we start from this, and we will, and what we are going to do is we are trying to find an intersection of these and the rest of the word, right? So we will keep the we'll start from we will initialize or we start from this, and we will updating our comment, like we're going to update this one by trying to find an intersection of by trying to find the common characters in the word array. So let's say we have label, right? How many let's say how many B's we have? We have only one B, right? So the minimum is gonna be one, right? So how many A's we have? We have only one A in a label, right? In label we have only one A, and label and these two words are the same. So this is not going to change, right? So for let's take the last word, right? Roller. So in roller, how many A's we have in roller? We have zero, right? So A is gonna be removed, right? There is no A here. So how many E's we have? We have one E, right? In roller, right? A will remain, right? E is not going to change. How many O's we have? We have nothing, right? We have no O's in this one, right? In the first, right? So we are not going to change anything. But how many L's we have? We have two L's, right? In a roller, we have two L's, and also in this one, we have two L's. So this is not going to change, right? So the one that remains, right? But one thing, how many B's we have in a roller? Sorry, we have none, right? So B is not, is going to be removed, right? So the last the last counter dictionary is gonna be like E is just is gonna be one, and L is gonna be two, right? We have this kind of dictionary will remain, right? Counter dictionary is gonna be remain, right? So we iterate over this dictionary, and we will we will append all of this, including the duplicates in our answer, right? So what I'm going to do is I'm going to implement this way. I'm going to implement this way. So the time complexity would be like, since we are just going to so as you can see, like the as you can see, the word length is going to be 100, and each of the words can be also 100. The length is 100. So n square could pass, right? If I iterate over, if n square definitely pass, so we don't worry about that. So it's going to be 10 to the power of 4. So n square would definitely pass. So I'm going to solve this problem in an n square time complexity, and the space complexity is going to be O of n, right? So in O of n and of n square time complexity, and it's right the time complexity is just it's gonna be of n square. It's gonna be of n square, and space is gonna be complexity gonna be it's gonna be of n, right? So I'm going to solve this problem this way. So first, let's say have my common, right? Let's say common is just counter. I import from counter. We have in Python, we have a collection. From collection, we have counter, right? It's count the frequency of the frequency of the words, the characters in this array, in this the words at table, right? So we start from one, one up to n. What we're going to do is just we need common and an intersection. In Python, we have an intersection is we when we want to find an intersection with this ampersand operator. So we will counter of the word the word at this the I position, right? Then we are returning list of in Python we're gonna have an element. So it's gonna there is a function called element. It gives you it multiplies the characters by their frequency. So it's gonna give you this way. So our answer is gonna be like this one. So let's check whether it works or not. So let's run and see how it's gonna be. So so the word is not different, right? So let's yeah, it's gonna be words. So also here words, right? Yeah. So let's see what's going to happen. Okay, internet is not available. Okay, check. Okay, and it's not defined. Okay, let's take and it's gonna be lane of words, right? Okay, okay, okay. Counter object has no element. Okay, elements. Sorry, it's gonna be elements instead of elements. It's gonna be elements, right? There is no elements function. It's gonna be elements. So it multiplies the characters by its frequency. This elements gives you an iterator, right? It gives you an iterator. Then we change this iterator to a list. Then we return the answer this way. So I think the spending is taking too much time. Okay, what do I do? Let's change the Wi-Fi. Maybe see. Maybe the Wi-Fi is not working. Let me change the Wi-Fi and see. Okay, my Wi-Fi is a little bit not working currently. Yeah, it passed. So let's submit it, and you can see. Go ahead. Yeah, it's passed, right? So as you can see, come on, it's taking too much time. Yeah, so as you can see, uh, this was the whole implementation. Thank you very much.